Alright, good evening guys and girls, and this is going to be our tutorial this evening over lesson 2-10, variables and expressions. And I will warn you, we're going to go back and forth between a PowerPoint and Smart Notebook to do some examples with, so hopefully it won't freeze up in between the two. So let's go ahead and get started.
Oh dear, oh dear.
Expressions, variables, and constants, oh my, what do these mean, and what do they have to do with math? So in today's lesson, you're going to be seeing a couple of vocabulary words here. We're going to see expressions, and expressions are mathematical statements that use a variable, a constant, and an operation. So in order for this problem to be an algebraic expression, it has to have a variable, a constant, and some form of operation. So you see here on the PowerPoint an example of an expression, x plus 4. The variable is the x, it's our unknown value, and the constant is our 4 in our expression example, and a constant is a number that will always stay the same. So a constant is the number that is connected to the variable in the expression. And then of course you have the operation. What are we doing to solve for that expression? Okay. Variables. A variable is an amount that can change, and you can insert many numbers in its place. So I want you to think about our algebraic patterns that we were doing last Friday and yesterday. We had many numbers in our input and output tables that we were trying in place of that variable. So when we put the number in the input into that expression, we would get the number that was the output. A variable can be written as a letter such as X or P or H or any letter that you really want to use. And you can change the amount of a variable by putting numbers in place of it. So for instance, we have X plus 4. You can plug in 6, 8, or 15 in place of X, and we would get, let's try this on our Smart Notebook. So say for instance, we had a table. Okay, and we had X, and it was X plus 4. And we're going to write the expression over on this side. If we had, let me check my numbers here, 6, 8, and 15. So if we're going to put 6, 8, and 15 in place of X, that would mean we would have 6 plus 4. Eight plus 4, 15 plus 4, and that would mean we have 10, 12, and 19. Okay, let's say we have our expression X plus 4, and we were going to plug in 6, 8, and 15 for X into the expression x plus 4. So we're going to put 6 in place of x. And when we put 6 in place of x, we get 6 plus 4 equals 10. We're going to put 8 in place of x plus 4, and that equals 12. And we're going to put 15 in place of x plus 4, and that equals 19. So our answers would be 10, 12, and 19. Okay, so that was an example with variables. A constant, again, is something that does not change. A constant in an expression is what you will always do. So it would be the operation and then the number afterwards. So in the example, in the expression y minus 6, the part that does not change is that you will always minus 6. Okay, different ways to write expressions. For addition, you might see x plus 3 or 9 plus h. Both of those are correct. In subtraction, you might see b minus 3 or 16 minus t. And that'll work into tomorrow's lesson. Subtraction is a little tricky. This is saying b or some number minus 3. This could possibly be saying 16 is less than a number. Here's a special note, and again this goes into tomorrow. Note that 16 minus t is not the same as t minus 16. You would get a different answer if you plugged it in for t, even using the same number. Just like 16 minus 2 is not the same as saying 2 minus 16. You would get two different answers. So, more ways to write expressions. Multiplication, and how we will normally write it, will be 7r. But you might see it as 7 times r tomorrow. You could also see it as 7 dot r, but that's not on the slide. But the number always comes first. For division, you might see an 8 and then a line. That line is a division sign or a division bar divided by m. Not the same as m divided by 8. You would get two totally different answers. Okay, so we're going to give these a try, and we're going to plug 2, 4, and 8 into some different expressions. We're going to switch over to our Smart Note. Okay, so now we're just going to do a couple of practice problems here. Let's say we have x and we have 11 minus x. And we're going to use 2, 4, and 6 to evaluate the expression. And evaluate just means that we're going to solve for the expression. Okay, so again, evaluate means to solve. Evaluate equals solve. So we're going to plug in our number in place of x. So we're going to have 11 minus 2, and that will equal 9. 11 minus 4, that will equal 7. And 11 minus 6, that will equal 5. So in the lesson that you'll be doing tomorrow, you'll be given a lot of charts. And within those charts, you'll have to solve for various numbers. So let's just try a couple more here. We'll use the same chart, and this time x in our expression is going to be 4x. And we have in the numbers 3, 5, and 7. So we'll plug in 3 for x. That's going to equal 12. We're going to plug in 5 for x, and excuse me while I write the problem backwards there. That's going to be 20. And then 4 times 7 equals 28. Now, you might have a chart tomorrow where it gives you, we're going to take that off of there, I clicked too fast, and it gives you a big chart like what you would see here, and it gives you x, and then it gives you a whole bunch of different expressions. Okay, and let's say all of our values are 2, 4, 6, and 8. So then we would just do the same thing that we have done on our small charts. We're going to do 2 plus 4 equals 6. 12 minus 2 equals 6. X squared, 2 times 2 is 4. 2 minus 1 equals 1. And 2 times 2 plus 1 equals 5. And then you would just continue the chart. So I hope this helps you with variables and expressions. Don't forget, we need to know variable, constant, and what expression means. If you have any questions about any of those terms, make sure that you write down your questions inside your math journal and bring those tomorrow to class. Thanks a lot. Thanks for watching. See you tomorrow.